Hello everyone, I'm Mai Mohanty, a high school student and a member of the Wolfpack CubeSat development team. Today I will be speaking about a certain CubeSat mission called the WolfSat-3, and I will explain what a CubeSat is, the accomplishments performed by the Wolfpack CubeSat development team, the overall basis of the WolfSat-3 mission, how this is applicable to space travel, and preliminary research. Before I begin more about the details of the WolfSat-3 mission, it's important that we know what a CubeSat is. CubeSats are small satellites that are very cost-effective learning tools that are used to perform experimental procedures in the space environment in a timely manner. The concept and first CubeSat was created in the late 1990s and is a 10 by 10 by 10 centimeter cube. And to put that into perspective, it's large enough to hold a softball. CubeSats are used by many educational institutions and governmental departments such as universities, schools, and even the military. The Wolfpack CubeSat development team, or the WCDT, was established in 2020 by a group of students and their science teacher, Mr. Kevin Simmons. The team is composed of students ranging from elementary school students to high school students. Mr. Kevin Simmons is also the founder of Blue Cube Aerospace, which strives to build, test, design, and launch CubeSat technology with student-led teams from different backgrounds. In December of 2018, the Wolverine CubeSat development team, which is the preceding CubeSat development team, successfully launched the WolfSat-1, a 1U CubeSat chosen to fly by the 24th round of NASA's educational launch of nanosatellites, and in NASA's 8th round of the CubeSat Launch Initiative, or CSLI missions. Additionally, the CapSat-1, a 1U CubeSat, was chosen to fly through NASA's 10th round of CSLI and is scheduled to launch later this year. Students from both teams, past and present, have launched high-altitude balloons as a way to train and educate the young minds of the team. Additionally, members from both teams, along with their instructor, Ms. Shauna Christensen, the founder of the Aerospace Public Policy Institute, participate in many legislative sessions, blitzes, and work on resolutions at the local, state, and national level to expand on STEM education and to provide awareness, educational benefits, and more opportunities to students and teachers in Title I schools, a model which can be implemented universally. The members of the WCDT introduced a state resolution that was supported by Brian Mast, a Florida congressman, and is known as the House Resolution 85. The House Resolution 85 aims to increase awareness about NASA's CSLI program and to provide hands-on STEM opportunities to teachers and students in Title I schools. The WCDT past and present teams have participated, attended, exhibited, and presented at various conferences at the local, state, national, and international level to encourage the young student members to engage in the STEM pipeline at a young age. The WCDT is also involved in a high school chapter of the Palm Beach County AIAA and has attended and hosted many AIAA banquets and functions. The WolfSat-3 mission is a mission that is based on education. It has a secondary priority of being a biological-based mission. On the WolfSat-3 team, we find it very important to educate the members in order to enhance the STEM pipeline and encourage students to pursue STEM careers in the future. Additionally, the second part of the mission is a biological payload, which will monitor the behavior and production of voltage by the Geobacter metalloreducens in the harsh environment of space. The WolfSat-3 strives to innovate on techniques of sustaining life in the space environment. Both manned missions and ISS-based missions have had challenges in the past with providing clean drinking water to astronauts and scientists. Many techniques and technologies in the status quo that are dedicated to the purifying of water in space and on Earth require high amounts of energy, large pieces of equipment, exorbitant costs, additional chemical additives, and do not have an efficient method of disposal for the contaminants. Since the 80s, NASA has been using iodine to disinfect and clean water, a process that requires the water to be filtered since too much iodine can cause thyroid issues. However, by using the Geobacter metalloreducens in the space environment, purifying and decontaminating water will be cost-effective, safer, and more energy-friendly. Additionally, the voltage produced by the Geobacter metalloreducens can be used to power certain components of the mission. Geobacter metalloreducens, the primary asset and primary experimental group of the mission, will be tested to improve today's status quo and demonstrate that the microorganism's ability to be insuperable by other products. The WolfSat-3 will utilize an Arduino as a voltage recorder and will collect data readings every tenth of a second. By analyzing the behavior of this bacteria in the space environment, a better understanding of the decontamination process can be obtained and can result in efficient and sustainable technology dedicated to decontaminating water. Specified technologies and methods could be developed based on the ability of the bacteria to survive in space. Because the geobacter metalloreducents are also able to utilize insoluble electron acceptors of contaminants, this gives the organisms an advantage over other bacteria that only consume the soluble form. Geobacter metalloreducents are a type of bacteria that utilize electrical energy to breathe and survive in their environment. The organisms oxidize several short-chain fatty acids, monoaromatic compounds, and alcohols with ferric oxide or iron 3 oxide. The organisms also utilize other metals such as iron for energy and will convert iron 3 to iron 2. Microorganisms that use the insoluble iron oxides as an electron acceptor can have an important function in the carbon and nitrite cycles of aquatic sediments and the bioremediation of organic and metal contaminants in groundwater. When these organisms happen to run out of dissolved metals, they just grow a flagellum, swim around, and search for more metals. Geobacter metalloreducents consume some radioactive elements as well, and they consume the contaminants. The organisms change metals from a soluble to an insoluble form. The insoluble metal isn't in the groundwater, thus decontaminating the drinking water. In addition to producing the insoluble form of the metal, the organisms also produce electricity as a byproduct, which can be used to power certain devices on a mission. In recent years, many research experiments have been conducted to seek an alternative and renewable energy source to replace our current dependence on fossil fuels. Some studies are being conducted on this bacteria and its relatives to see if the organisms can convert chemical energy from a wide range of organic substances directly into electrical current, which can be utilized. Certain studies show that the amount of electricity produced by a microbial fuel cell, which is a battery that contains bacteria that generate electric current containing the geobacter metalloreducents, was significantly higher than the amount of electricity that was produced by previous microbial fuel cells. The results conducted by this experimentation show that the geobacter metalloreducents battery had an excellent long-term stability. Additionally, the geobacter metalloreducents recover electrons as electricity at a rate of 80 to 95% as opposed to previous microbial fuel cells, which recover electrons as electricity at a rate of 1 to 50%. The fact that the geobacter metalloreducents are recovering electrons as electricity at a rate of 80 to 95% shows that this bacteria will be able to decontaminate the water more efficiently. In 2020, I conducted a study on the geobacter metalloreducents to determine a sufficient energy source for the bacteria. I studied the bacteria in various environments that were contaminated with different metals. For this study, over 580,000 data points were collected, meaning that the results of the study are very reliable and accurate. And as you can see in this table, when the geobacter metalloreducents were placed in their normal environment without the contaminants, they produced an average of 0.0113 volts and 0.05 milligrams per liter of hydrogen sulfide, which is a byproduct. When the bacteria were placed in the chromium-4 contaminated environment, they produced an average of 0.0135 volts and 0.1 milligrams per liter of hydrogen sulfide. In the iron 3 oxide contaminated environment, the bacteria produced an average of 0.0144 volts and 0.5 milligrams per liter of hydrogen sulfide. The data collected from the study confirmed the hypothesis that I developed. The geobacter metalloreducents produce more electricity and hydrogen sulfide in the iron 3 oxide contaminated water than in the chromium 4 oxide contaminated water, meaning that the organisms were more effective in decontaminating the iron 3 oxide environment. Additionally, this study confirmed that the use of iron 3 oxide as an energy source for the bacteria will be used on this WolfSat-3 mission. And thank you for listening and watching this presentation.